Okay, so now I'm going to be taking you through some more complex equations, and at a later stage we will look into some inequalities. It might be after a few lessons before we start with inequalities, but I would like for you to just be aware that when we talk about equations, obviously what comes to your mind, it is that equal sign. So that means whatever that we are going to be dealing with, it will be having an equal sign. What are inequalities? So it's either you've got something which is equal or not equal. Just interpret it in that way to say we've got equations where the left is equals to the right hand side, and inequalities is the opposite of equalities, which means in equality we will be looking at the left hand side not being equals to the right hand side. And definitely if things are not equal, it's either the other is greater than the other one or it is smaller than the other one. So that's why we will be having more of this signs of less and another one of greater than. It doesn't end there. Depending on the nature of the equation, sometimes you will be having less or equals to, then having greater or equals to. I just wanted you to be able to notice the difference between equations and inequalities. You will spot them by those signs. So we are going to start with equations, which is going to be a continuation of what you've already done under introductory lessons, definitely at a higher level. So it might not necessarily be a lengthy lesson, but you will definitely after this lesson do a lot of equations to solve. So let us start with our equations. If you remember, I did mention that we've got two main types of equations that we are going to be looking at. The first type of an equation, we can simply talk about a linear equation. Another one, it will be a quadratic equation, of which we will look into that at a later stage. So, under linear equations, you will just have a variable being a letter being equals to a number. This is how your final answer will look like. It will just be one possible answer. But when it comes to a quadratic, it will be a letter equals to a number. Then we will have another letter equals a number. So that means we will have two possible solutions or two possible answers. But the question now is, how are you going to know if you are dealing with a linear? How are you going to know if you are dealing with a quadratic? So linear is to the degree of 1. So those are equation of degree 1. I will explain that, but let me just simplify it and say degree 1. So that means this one, it would be something of degree 2. How so? Okay, let me explain the same. If you have x squared that you plus it with, it could be 3 equals to 0, and then here we can still say x that you plus it with y, maybe it's equals to 1. So when we say something is to degree 1, you look at the letters in the given equation. If the highest exponent from those letters is 1, then it is that one under linear equation. So you see there is a letter, there is a letter. All the letters are to the exponent of 1. So I think it is easier to conclude and say when it comes to a linear equation, all the given letters are to the exponent of 1. That will be a linear equation. And then if in the given equation one of the letters is to the power of 2, automatically it makes it a quadratic equation. Doesn't matter if you have this to the 1 and then also this to the 1. As long as one of the letters is to the 2, then you know it's a quadratic equation. That's how you spot a quadratic equation and a linear equation. So maybe let's do an example there and say, let's say we have 3 where maybe let's minus 4, and then inside the brackets let's have k, that we plus it by 2, maybe let's equate this, let's just say to 3k, that we plus it by 16. Okay. Alright, then it's fine. If it still has a bracket, do not conclude by saying it's a linear or it's a quadratic. Firstly, remove the brackets, work out the like terms, just like you would do in the introductory lessons. And then once you've done that, look at it and make a determination whether it's a linear or a quadratic. So that means we need to first remove the brackets where we do that by that, that by that, which means we are now having minus 4k there, minus 8 there, which will be equals to, can still say 3k, that you plus it by 16. So let's see, that by that, yes, is that by that, yes, is that, and then we have that. So now we work out the like terms. So before we even work out the like terms, we can see we have that letter, that letter. All the letters are to the exponent of 1. Then it means this is a linear equation. How do you deal with it? Letters one side, numbers one side. So we can still say we have negative 4k, bring that to the other side, it becomes negative 3k equals to 16, already it's here. 3 comes this side, it changes the sign, and then 8, it goes to that side, it also changes the sign. Here we have negative 7k, which will be equals to that and that is 8 minus that, it looks to be is it 5? Nope, it's not 5, but it should be that plus that is it 24, that you minus it by 3, then it becomes 21. Yes, it's going to be 21, and it's going to be 21. Remember, you need to detach that because it is actually k that you are looking for, and it will definitely be equals to, but remember we divide by negative that, it will be negative 3. Yes, it will be negative 3. So this should be the end of it. So now let's look at another example. Definitely you won't need a lot of examples, just these 2 examples will set you up and get you ready to start doing similar problems. So the second type of a problem that I'm going to give to you, it is this one, of which we will work it out together, where we have a 4x minus 1 that we can divide by 3, and then we minus this by, and then we are having that needs to be added with that, and we divide it by 6. Then we equate this thing with x over 2. What is this? All I can say is that this is an equation because I see an equal sign. So, because it is in the form of a fraction, I don't want it in the form of a fraction, I will need to remove the fraction. Look at what I did before I fully understood this thing of the LCD and all of that. What I would do is to just take those denominators as they are. I just take them as they are, and then I just multiply each and every term with that. This is what I used to do before I understood this thing of the LCD. But it got to a point where I realized if I have to multiply with all of this, it may be a lengthy calculation or a calculation with big numbers. So if you want to go through that route of the LCD, then you will need to know what the lowest common denominator is, of which when you look at 3, 6, and 2, the lowest common denominator is definitely 6, because 6 goes into 6, 2 goes into 6, even 3 goes into 6. That is the lowest number of which all those numbers can fully go into that without you having a decimal or a fraction. That's just what we want. Okay, then whether you have this or you have that, it will take you to the right answer. So let's see. What it means is that you need to multiply each term by that LCD of yours. That's what you need to do. Why would you do that? Is because you want to remove it from being in that format of the fraction, and you just want to have something which is just a flat equation without the fractions. Yes, you see now. Then what you do, it looks like I'm going to run out of space. It's fine. So definitely this over that, what will that be? It will definitely be 2. So it's like you are having 2 into 4x minus that, and then that into that, it goes one time. So that's why you have 1. You can still say 7x. That you plus it by 2. I'm trying not to take shortcuts. That into that goes 3 times. So you can just say 3 into x. So just be careful with that step so that at least you've got an idea of what is going on over there. Now that you've done that, you can now say that by that, where you have your 8x minus 2, that by that, it will definitely give you negative 7x. That will change the sign to making it 2. Then that by that, it will definitely make it 3x. So now you have this minus that. What will that be? It's definitely going to be positive x. So it's like you have positive x. And then you can still take this to the other side if you like and make it negative 3x. It doesn't really matter that much. And then you have negative 2, that you plus it with 2, they definitely cancel out. It's like you have 0. That 0, you can take it to the other side, still fine. You just need to be aware that 0, whether it's positive or negative, it is the same. That's why I'm writing it as positive 0. So now, because of space, I will say it's like I'm having that x minus 3x, which is equals to 0. This will definitely be negative 2x, which is equals to 0. But wait, Why is it like I made a mistake? Why is it like I made a mistake? No, I think I've done everything correctly. Yes, I think I've done everything correctly, because that one is x, and then let's see. Oh yes, I do notice my mistake, and I'm suspecting that you too noticed that mistake, and I'm glad I made this mistake, because at least you will have an opportunity to not repeat my mistake in an exam. So let's see, the mistake that I made was regarding the sign. You see there, when you say that times that, it definitely gives -7. But when I did that by that, I took it with its positive sign, of which it's not supposed to be positive there, but it is supposed to be a minus. So that means with it being a minus, now things will change. So you've got 8x minus 7x, definitely that is x. So that means you will have -2 minus 2, which will be -4, or minus 4, which should therefore be equals to that 3x. Maybe let's not take a shortcut there. So now you can still say, okay, I'm having x, I'm taking this to this side, it's fine. Taking 4 to the other side, it changes the sign. So you will just realize that maths is not necessarily complicated, but it's all about testing if you are able to pay maximum attention on what you are doing. Because one small mistake, then it means everything is wrong. So you are trained on paying maximum attention, because an assumption is that once we teach you the rules, you now fully understand the rules, you just apply, but while being careful. That's all that you're being tested on. So that when you become a medical doctor and you have to perform a surgery, you will not make any mistakes, because there is no room for a mistake, honorable member. Everything has to be done accurately, everything has to be correct. So yes, that's all that I wanted to take you through for today. So I've got some nice exercises for you that you will have to attempt, and based on your attempt, then it will tell whether you do have a better understanding of the linear equations or not. Maybe on our next lesson, I will therefore take you through quadratic equations. So between quadratic and linear are more easier than quadratic, because when it comes to quadratic, it involves what we call factorization, which is the tricky part, and even the guys in 11 and 12, they still struggle with this part of factorization, and I will show you how you need to study it in your current grade. But trust me when I say when you get to grade 11 and 12, it's easier, it's way much easier. So I was fortunate enough, because I was studying ahead, to notice that actually this thing can be factorized in this way. And once I figured out how to do it the easier way, then even when I was in grade 10, I used to do it that same easy way. And that's why I think I was doing good in maths, because without factorizations, you are not going anywhere. You can't deal with the functions, you can't deal with problems involving quadratic, because you always need to factorize. Okay, I'll leave it here and say